Hello to my friend and Miss Azrina. Today our group will present about Acetylene or gas welding. I will introduce our team first. My name Muhammad ANASZERI'Y bin Muhammad Nordin, metric number 09 DKM 23F1035.
Hi, it's me, Muhammad Akmal Hakim Mirosli. My matrix number is 09DKM23F1026.
Hi, my name is Noor Ahmad Fauzi bin Muhammad Zain. My metric number is 09 DKM 23F 1047.
My name is Amir Omar Bizamli. My metric number is 09 TKM 23 F1098.
Introduction. Gas welding is a welding process that melt and join metal by heating them with a flame caused by a reaction of fuel gas and oxygen. The most commonly used method is oxyacetylene welding. Due to its high flame temperature, the flux may be asked to deoxidize and cleanse the weld metal. The flux metal solidify and form a slack skin on the result weld metal. Principle. The basic principle behind most type of welding remain to melt the two metal by heating the above their melting point and flux and fuse them. Let us learn the working principle of gas welding. The metals are made by the heat from the reaction of fuel gas, acetylene, propana, butana, hydrogen, and oxygen. When the gas from the cylinder stored at high pressure are released, they flow through the torch at high velocity and are mixed. The mix has high temperature with trace of carbon dioxide, and this is ignited by external spark. The flames start blowing from the touch. The heat from this flame can be enhanced by increasing the pressure of flow gas.
Of welding. Oxyacetylene welding, commonly referred to as gas welding, is a process which relies on combustion of oxygen and acetylene. When mixed together in correct proportion within a handheld torch or blowpipe, a relatively hot flame is produced with a temperature of about 3200 degrees Celsius. The chemical action of the oxyacetylene flame can be adjusted by changing the ratio of the volume of oxygen to acetylene. There are 3 points: oxidizing flame, neutral flame, and carburizing. Welding is generally carried out using the neutral flame setting, which has equal quantities of oxygen and acetylene. The oxidizing flame is obtained by increasing just the oxygen flow rate, while the carburizing flame is achieved by increasing acetylene flow in relation of oxygen flow. Because steel melts at a temperature above 1500 degrees Celsius, the mixture of oxygen and acetylene is used as it is the only gas combination with enough heat to weld steel. However, other gases such as propane, hydrogen, and coal gas can be used for joining lower melting point, non-terrestrial metals, and for brazing and silver soldering. 4.0 Welding equipments. First, let us refer to the image below while learning the parts involved in the gas welding. Oxygen regulator, oxygen safety valve, torch oxygen valve, torch fuel gas valve, oxygen cylinder, oxygen hose, fuel gas hose, fusible plug, fuel gas regulator, fuel gas cylinder, fusible plug. Regulator is used to adjust the required pressure at which the gas should be released for the operation. B. Fusible plug is a safety valve which is used when the pressure in the system goes beyond the optimum. Plugs are usually made of tin which has a low melting point. C. Hose. They are simply pipe that are designed to allow the flow of various gases without reacting with them. Usually, every gas welding equipment has two hoses, one for oxygen and the other for fuel gas. In India, oxygen has a standard color of black and acetylene has red. The non-return valve. These valves are essential to prevent the oxygen and fuel gas from flowing back into the cylinder, which may cause the cylinder to explode. E. Check valve. It is a chamber with a ball pressed against one and through a spring. The check valve is used to add the flow in one direction. Torch. F-torch. This is the working tool that the operator uses to make the weld. It is the gateway from the final output of reaction from the cylinder to the metal. Point 2. Refer safety equipments. Bearing protection, welding helmet with a flash filter, cap, goggles, dark flame-proof clothing with long sleeve and neck fastening, apron, glove, full PPE, steel-capped boots. The risk of starting a fire or being burned is high with oxyacetylene cutting. It's important to prevent molten slag and spark from coming into contact with skin and flammable material. Make sure you are wearing heavy-duty gloves with gauntlets, a leather jacket or leather sleeve jacket, and the leather boots. The whole area should be clear of flammable material. If an item will be cut in place, make sure surrounding areas are protected from heat, sparks, and dropping slag. Never outseal tank, cylinder, or item that have contained flammable materials, and never cut gasoline tanks or fuel lines.
5.0 Shielding gas. 5.1 TIG welding, tungsten inert gas. Purpose similar to MIG welding, TIG welding utilizes a shielding gas to maintain a clean environment during welding process. Common gas, poor argon is commonly used in TIG welding. Role of shielding gas. The inert gas shield both the tungsten electrode and the weld pole from the air, preventing contamination and ensuring a precise, high-quality weld. Application: TIG welding is especially suitable for thin material and produce fine, intricate weld. It is commonly used for material like aluminum, stainless steel, and exotic metal. 5.2 MIG welding, metal in a gas. Purpose: MIG welding use a shielding gas to protect the welding area from atmospheric contaminants. Common gas, typically a mix of inert gas such as argon and or helium along with small amount of active gas like carbon dioxide. Role of shielding gas: the shielding gas form a protective barrier around the welding arc, preventing oxidation and other reaction with the molten metal. Application: MIG welding is versatile and widely used in various materials including steel, aluminum, and stainless steel.
Electrode. On the other hand, TIG tungsten inert gas welding as a non-consumable tungsten electrode. The tungsten electrode does not melt during welding. Instead, it generates the arc by carrying the electrical current. A separate filler rod made of the desired welding material is added manually to the weld pool. The arc of inner gas typically argon shield the weld area from atmospheric contaminant, ensuring a clean, high quality weld.
In MIG, metal inert gas welding, the electrode is continuously fed wire that serves two purposes. First, it acts as a filler material that melts and fuses with the base metal, forming the weld. Second, the wire also functions as the electrode, delivering the electrical current to create the arc. The wire is typically composed of the material being welded and may be solid or flux core. 7.0 The advantages and disadvantages of acetylene welding or gas welding. Advantages of gas welding. It is a heavy section that cannot be joined economically. Flame temperature is less than the temperature of the arc. It is a very simple piece of equipment. It is easy to operate and does not require a high-skilled operator. It can be easily maintained and repaired. Disadvantages of gas welding. Heavy section cannot be joined economically. Flame temperature is less than the temperature of the arc. More safety problems are associated with the handling and storing of gases. Gas flame takes a long time to heat up the metal than the use of arc welding. Acetylene and oxygen gases are rather expensive. Conclusion. In conclusion, gas welding, particularly oxyacetylene welding, remain a versatile and widely used technique in various industries. Its ability to achieve high temperature makes it suitable for joining metal, cutting, and brazing. Despite advancement in other welding methods, the precision and flexibility offered by gas welding continue to make it a valuable choice for certain applications, emphasizing the importance of the skill, craftsmanship, and safety practice in harnessing its full potential. Thank you. Sorry if this presentation is not perfect, because the only perfect thing is us who have been together.
Bye bye.